Test, test. Test, test, test. Yeah. I have a clock there. 1 minute more. Yeah, please. We really need talks, speakers for the next meetups. And there will be plenty, and we are planning one in December, in the middle of December. Please write me in meetup.com or in the application if you want to. Thank you. So it shows 7:30 for me. Hi, my name is Anton Kotenko, and I work in JetBrains in CAI, not CIA, which is short for Computational Arts Initiative Team. And I'll tell you about the basics of generative everything. Not everything, like I can help you generate a BMW car, no product placements here. However, we can generate you the tickets to React Days Berlin today, but this will come later for lucky 2 winners. There will be not a lot of code in today's talk, but when it appears, please consider it purely functional, and all the concepts I'm talking about are purely functional as well. This is the logo of the team I'm working at. There's a lot of history in creating it. I mean the team, not the logo, but maybe also the logo, and how it keeps being at the moment, which I could tell you by the slices of pizza if you want. What we do is, using automation, we help designers to get rid of their routine and let them focus on ideas and exclusive creations. Probably you've seen the splash screens for our products. This is one of the things we produce in the team. Of course, there is a creative control over us. The things we produce go through the steps of perfectioning to match the brand and the style. And for sure, there are a lot of things we produce that didn't pass the first steps of such control. Speaking in modern language, the designers are meticulously counting all the fingers on the images we do. Enough for self-presentation, closer to the topic. What is everything in my talk in the end? I thought about telling you about 42 of things, but then I decided to focus on just 2, music and visuals. What I mean by visuals is what happens on the screen on the techno or live coding parties. If someone ever was to Harry Klein nightclub here in Munich, they used a corner between two walls for visuals of that kind, which was the height of two stores just behind the DJ. Nowadays, the nightclub is closed. All in all, I plan to demonstrate to you what algorithms they have in common, like music and visuals. Please be aware that there will be a lot of colors and glitchy things in the presentation, just because not everything generated looks or sounds beautiful. Sorry for that. Always apply some sense of the painter or musician to the images or sounds you produce. I have neither of these talents, so my presentation is a mess. At first, I will show you some pictures and suggest you to find something generic or general between them. On the left hand here is VCV Rec, the application that allows you, well, maybe I should do that, that allows you perform live music from your laptop by plugging in virtual chords in the right sockets. Or the wrong ones sometimes, as I usually do. Just like those people who bought themselves modular synthesis instead of BMW for quite a lot of money, they use this software. No, they use the Eurorex, the physical stuff that is represented by this software. On the right-hand side, there is the Hydra engine for visuals, and I'll tell more about it later. Here is the code for the Hydra engine for this particular picture with a little bit of zoom. So another pair of pictures. On the left-hand side, it is Sonic Pi, the thing to play music by writing the code in Ruby language. And on the right-hand side is still Hydra engine. And once again, I've zoomed code a little bit in. Now, on the left-hand side, there is the pure data, the software, the tool for generating music. Metro means the metronome here, and DIC means digital to audio converter here. And also the same code. Here on the left is Tidal software, the software to write live music in Haskell. On the right is the live coding performer. Behind her there are two screens, recursion here. One with the code from Hydra engine you've seen before for visuals, and another one could be Sonic Pi or Tidal or some other audio live coding tool. She does that to accompany her appealing music with some appealing visuals that react to the sounds. And the final pair, the true modular synthesis rack and the documentation for Hydra engine, the code for which you've seen before. And probably someone of you could notice what I'm leading to. Have you seen any general stuff between those images? Maybe someone has an idea.
Some gradient?
Yeah, some gradient. Yeah. Good. Yeah. And also there was until later. Yeah. 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 This is the most important thing. Right.
Did you also show like same code for image and for music?
No, unfortunately, no. Yeah, this is a good idea. Yep. In this image, we can see that all the functions that produce visuals are grouped by some categories. Source, geometry, color, blend, modulation, some external sources, and audio, and others we'll skip, we don't need them. One of the sources is an oscillator, as you've said. Please notice that for future discussion. Also, there is the SRC function, which is the source and itself as a source. And also, I'll cover it later. I think it is convenient to treat external sources, which are here in the blue, the same as just sources. Those are for camera and video or video stream, or taken capture from your display. These are documentation pages for APIs from some popular generative art frameworks, such as Paper.js for 2D, 3JS for WebGL, or A-Frame for virtual reality. The methods in them are not grouped in the same way as for Hydra, but I think if one considers the abstractions, they may reach the enlightenment. So let's get to the basics of both music and visual art. The oscillating wave. Sine wave, for example. For music, it is the source of the sound, and both is in software and in hardware. This wave is infinite. It just makes the plain sound of particular frequency. I decided not to do any sounds here. If you're doing modular synthesis, it is the source from where all your wires take the origin. There could be several oscillators, of course, and for example, to make the techno beat, you cut out the portions of this wave during time. And if you want, of course, if you don't want your sound to be synthesized from pure biological wave, you may use a sample file. But if you open your sample file in the sound editor, you'll see that it's a wave too. For visuals, it is the color wave. For example, if you use subtractive method, then every color is produced from white color. Here is the low frequency oscillator from some, for example, Ableton. It's from somewhere else, maybe Fruity Loops or something, and some different waves to produce sound, the sine wave, the square wave, the triangle wave, and the saw wave. The saw waves are more buzzy, and square waves are flat, sounding flat. On the right, you may see the oscillator, which is the source for a lot of things in the Hydra engine. It is just black and white. And if that wouldn't be an image, you'd see that it's moving horizontally with the default frequency, which of course could be changed using the arguments. And here is the code. It's just oscillator and put it out on the screen. Noise is also a wave, just a bit funky kind of wave. And in the visual perspective, it goes in 2 or 3 dimensions, like on the right. Also, when you do audio, you take your audio wave and modify it with filters, and filter the things that affect the oscillating wave. Pictures and color are also the subject to be affected by different filters. Filters take the wave, in this case the color wave, For example, here there is white light, and it's split in 3 waves, like red wave and green wave and blue wave. And it is, in case of magenta filter, it's only the green light is absorbed by this filter. It's the filter, the lens you use for the photo. And there are some graphs which show how the color wave is affected by the filters. After the filters, there is the modulation. When you produce music, it is when one wave is modified using the values from another wave. It could be used not only for fun, but also for really scientific stuff. For example, when you have had a radio station used for Morse signals, the signal could be noisy with no intention. It could be distorted. So to get the values for short and long signals, you amplify it with another wave, which takes the noise from the signal, and by combining them, you get the original signal almost perfect. And there are a lot of different ways of modulating the sound, the digital ones and the analog ones. And the image also could be modulated by using the value from the pixel, the brightness, or the red or green or blue component, or hue value. Another pixel could be changed not only by color, but also moved to some position on the XY axis. Say, for example, you take 2 images, one as a source and another as the modifier, make them both the same size, and when you have a lot of red value in the pixel of a source image, you take the pixel at the same position in the modifying image and move it proportionally to the right side by x-axis, for example. If there is not a lot of red value in this pixel, then another pixel gets closer to the left side of the resultant image where x is 0. And on this image, it seems the oscillator was used as a modifier for the modulating procedure. Here is one of the modulating functions in Hydra. There is some code below which uses different functions from the documentation I showed before. There is also an very interesting thing, the fast Fourier transform algorithm, which is used, for example, in geology for listening for the magnitude of the earthquakes. So it allows you to take, you actually listen the earth below and extract the, you make the signal softer, and this way you find the exponents, the maximum points of the signal, and if there are a lot or they're very frequent, that could be the sign that the earthquake is coming in future. So it's like prediction. And the same for Yegai, and it is actually pretty the same algorithm used for as Fourier series to vectorize the raster images. So you actually can get the vector from any image with some, you just define as the parameter, you define how it should be close to the original. So if we now return to the visuals, we can group the things we discussed into groups. One of them, for example, is source. No, we consider everything that is generated or shown on the screen as a texture. So the source is something like the solid color or the oscillator or the gradient which generates the texture. There are color functions that affect the texture. I will show the examples. The geometry functions that change the positions inside the texture, for example, scale it or rotate or something. There is blending that takes two textures and blends them with each other. There are effectors. This is some more complicated things I will show as well. And there is also the modulation we discussed, which combines also as blending two textures and generates another texture. And for example, for visuals on the live coding, when you code music, there is the input which is coming from the outside, and you affect a texture with it. For example, you listen for harmonics in the sound, which is higher, which is lower, and scale some shape on the screen or something like that. I just repeated the grouping again, so it's pretty similar what I've shown before with this. So there was the source, which also takes texture as the input. So you can, when you output some texture, for example, from blending, for modulation, from all the combinations, you may take it as a source, and it will also be a texture, something like recursion this way. So examples of source are solid color, for example, gradient or some shape, like the polygon or a spiral, or an oscillator, or noise, or Voronoi triangles, or also the reference, which is I talked before, to some another source, or the external one, like the image from camera or from some video stream. The examples of color functions are sterizing, shifting the colors, inverting the image, adjusting the brightness, using some threshold to filter, like the low pass filter with audio, for example. The geometry functions are the things that change the positions or rotate or scale the stuff, or for example tile it, or do the symmetry like mirroring or kaleidoscope. The blend functions are, with the few examples, there are truly a lot. If you use some image editor, there will be just a huge list of things. The effectors I will show a bit later. Modulation is the thing that uses one texture, like the dynamic texture, something that moves. And as I described, it modifies the pixels of another texture by position or by color or by something like that. And the latest is using some input as the time, current time, or frame number, or mouse position, or audio harmonics to modify your texture. And actually, this talk was completely inspired by this image from one of the courses, which groups try to generalize the generating concept by also grouping them into a bit different groups, but still, and they had like very nice icons for that, like kind of self-explanatory. There are shapes, which are sources, for example. There is alignment, almost the same as geometry we talked about before. There are effectors, which, for example, you may take some source and modify its, how it behaves with another textures in some complex logic, like not only noise, but also for example, L system, which is like trees, you may position some textures like trees. And there is interactivity, which is the input for all the actions that happen in your visualization. And actually, that's it. I hope I delivered the idea. And please stay for the pizza, and there will be the raffle for the tickets for React Days in Berlin in December. And please, pretty please submit talks for the next Lambda meetups. We need more. Yeah, thank you. So if you have any questions, there was the microphone. Or maybe we can do it just like that. Do you have any questions?
So this Hydra is a kind of an engine, or what exactly?
Yeah, it's like the framework for visuals. And their core idea is that they looked at the modular synthesis for audio, and they thought that what if we try to apply those concepts, the same concepts for generating visuals? Yeah.
And same with the paper.js also.
Yeah.
Microphone.
Yeah. Please. Yeah.
Yeah.
Put it. Yeah.
You have a question?
I think so. I'll just switch.
I haven't seen any blogs here which do feedback or recursion. Basically, use some data from a previous blog in a succeeding blog or frame or whatever.
Yeah, there is for the functions in the Hydra. There is this previous function. It looks like it's not developed but it is there. It looks it takes the previous frame and modifies it, so you can do like yeah.
Since stuff you showed at the beginning, is this SuperPy or how it was called of pure data? This is a modern version of C sound, or
It's actually the very old thing. It was developed in 19th. And nowadays the concept of pure data is used in Ableton Live for the Max programming language, which looks kind of like this, but a lot more user interface and logic. Yeah. And pure data was on the Linux systems, I suppose, mostly, or maybe the. Oh, yeah.
was way ago, and then it was basically writing ABC samples in hand-programmed C code, and get something out. It actually worked. I get some magical sounds out of it, but this was way long ago.
But it keeps going like the the live code and stuff and everything it develops. Yeah. So it shouldn't be that hard nowadays. I hope.
Do you have any examples in this?
I have the Hydra engine. Do you mean in C or?
No, just show me.
Yeah. Um,
Maybe something that you have in presentation, right?
I can. uh, so there is the Hydra book, for example. It's not very useful. uh, this is like the tutorial on how to use this engine uh, for different things. Like these are shapes. Come on. Some of them on YouTube. I will also show the actual Hydra engine. Mm. So yeah, this is it. They have a lot of examples here with the code maybe. Yeah, this way. So they have oscillators and modulation and rotation and everything we discussed. And they combine them just for some of them do react on microphone or use the camera as the input. So that's it. Yeah, yeah, they were also inspired by it.
Do you use the Hydra to create the JetBrains?
Not particularly, but we have some parties with DJs, and I do sometimes visuals, and not usually with Hydra, but with Touch Designer, which is like have similar concepts. Yeah, and what we do.
So the output here is a video file, or is it, what is the output of this? Like when you say dot out, so what it basically generates some sort of a media out of it, or?
It generates the texture, and you may also name the output. There could be several outputs, so that you could also combine them. That thing that I said, that source that references to another source,
Yeah.
this is this thing. Uh, uh, so you say out, for example, to output 1, and then you say take the source from output 1 and do something with it later. And so you combine different stuff and do not write a lot of chain functions. And here's our website and what we do. We have some different generators which were used for designs for different also webinars and stuff.
Unrelated question. What the hell are you using for window manager?
I don't know, just the native stuff. Yeah, maybe I should. It's the Arc browser. Yeah,
It's in the browser.
yeah, yes. So I'm not. I'm trying to get used to it, but not yet.
And regarding Sonic Pi, I thought Sam Aaron was like a Clojure guy.
Yeah, maybe. Yeah.
But like
Uh,
Sonic
uh,
Pi, was there like also a Clojure version of that stuff? Because like
um,
I think that originally he did
yeah,
it
it
for
came
Clojure,
from.
but then he did it for like Raspberry Pi, and then it became Sonic Pi. Is it? Or
Yeah, maybe. I did, actually for Sonic Pi I didn't follow it a lot, but yeah, could be.
Yeah, because
Because
I remember him from Closure community, but that was just fun.
I remember there was also some live coding tool in Closure, and still in Closure.
Quill, you mean, or
Maybe yeah.
you mean for graphics, right?
No, for audio.
For audio,
Yeah.
yeah, we did play with it back in the day.
Mhm.
I don't remember what that was, but I think that was like Scott era.
Mhm.
I even
Oh,
have
cool.
SoundClouds still from. It was Munich
Put
Dumbo
it
like
here.
10 years ago or something.
Oh, cool. So I think that's it. You're free to go. Yeah, please come to our website, which is CIA, CAI, JetBrains.com. So you're welcome.
Overtone.
Overtone, yes.